How's everyone doing today? My name is Quang Trinh, and I am the manager of the professional services team here at Axis Communications. For some of you that don't know who Axis Communications is, we've been around for a while. We started in the 80s doing print servers for the IT industry, and then in 1996, we actually invented the first IP camera, an actual device on the network running by itself without needing to be connected to a computer with a camera sensor. And then from there, we entered the security industry market where a lot of things were analog. And from that time to now, we've been really, trying to push the industry into moving towards accepting IP video. And now it's a norm. A lot of different organizations out there see IP video as the future of their infrastructure. And the most interesting aspect of us when we invented the IP camera back in 1996 was at that time we realized that there was not a lot of processing power that you can put on the edge to actually encode the images or the videos properly. So what that led to was us developing our own chipsets. So basically we developed an ASIC processor designed to just specifically do video encoding very well. And from that standpoint, we call that particular chipset ARPEC. And that stands for Axis Real-Time Picture Encoding Chip. And from 1996 to now, we've iterated in several generations of chipsets since then to improve the processing power at the edge. And right now, we're in our 8th generation chipset, and it's very exciting. And why does that all relate to AI? I'll give you a little bit of a background in terms of why it relates to AI, and that really comes down to is, if you think about AI, a lot of it's a huge buzzword right now, right? Similar to the buzzwords of like cloud and cybersecurity a couple of years ago. And right now, AI is a very transformative technology. It's going to change the industry and every industry, not only our security industry, but other industries that are involved. And from our standpoint, as a manufacturer of edge devices, what we did with our chipset is a little bit of a differentiator compared to what other companies have, because we actually control our own destiny. We design, we develop, we optimize. And about a couple of years ago, starting with our 6th generation chipset, we moved from ASIC to a SoC type of architecture. And with that SoC type of architecture, we were able to, embed a GPU into our edge devices so that we can do some additional processing and offloading because we were dealing with video. There was a lot of things that our customers wanted with overlays and things like that. But also at the same time in 2009, that was when we first brought out our software platform. It's called ACAP. So that's Axis Camera Application Platform. So similar to how you guys load apps on a phone, you can actually load apps and programs on the edge and run it and let it operate things that are just beyond what just the device was doing from a video perspective. So that ACAP platform started in 2009, and that's a very important piece because that allowed a lot of our developers and a lot of our partners to take advantage of the additional horsepower, the additional processing power at the edge to do some very unique things to enhance a lot of the solutions that they were developing at that time. So how does this all relate to AI? Well, the one thing about machine learning and deep learning under the AI umbrella is that it's becoming, in the forefront of a lot of different, companies right now. We're living in a digital age where everything is on the network, everything is digitized, and the data that's being collected from all these different devices are becoming more and more very valuable. And from that standpoint, machine learning has always been very structured. It's able to take information from databases, whether you're an online retailer with a database of customers' names, locations, zip codes, phone numbers, products. Machine learning was able to put together predictions and trends and things like that off of very structured data. Now, with the advancements of machine learning and their techniques and the evolution of that into deep learning and neural networks, a lot of the data that they're able to process is actually unstructured data, and they do that really well. And why does that relate to us? Well, on the video side, we handle a lot of video and images. And video and images are what a lot of the AI community call unstructured data. And they love that. They love to feed on that unstructured data so they can build models on things in terms of how they can, increase the intelligence of their models and their AI solutions. So from that, there's a huge synergy with the AI community and the community in the security industry, especially that these devices are on the network. They're already digitizing the data, the video data. And, this is a very huge inflection point that's going to help fuel that fire to breed up more innovation within deep learning and machine learning and neural networks to really elevate AI to the next level. And this is why there's a lot of analysts out there that are predicting that AI is going to accelerate exponentially over the next couple of years, if not the next decade. So this is very important when it comes to understanding, how that plays into what we do here at Axis when it comes to edge devices and what we're preparing them for the future. Now, the one thing is that, at Axis, we're very future forward thinking. So we like to plan things, 5-10 years ahead. And a lot of things that we do are in anticipation of a lot of these different technologies that might come into our industry and impact it in a very positive way. So with that, couple of years ago, when we had our release of our 7th generation ARPEX 7 chipset, we actually collaborated with a global company that developed their own ASIC processor, or their own tensor processing unit that handles deep learning, machine learning, and AI type of techniques. And it was a very well done architecture, and we worked with them to actually implement that chipset, that particular chip, as a co-chip within our ARPEX 7 devices, and that was released a couple of years ago, and that actually allowed a lot of our customers to evaluate and entertain a lot of the things that they were doing with AI. And going back to that ACAP platform that I told you about in terms of our application platform that we started in 2009 and that we evolved since then. The nice thing about this is that with AI, it's all about building models and seeing how much they can push that model down to the edge and what they can do from a processing standpoint, and from there seeing what they can do. And because we had our ACAP platform, it allowed for our customers to kind of experiment with a lot of these different image classification models that they were building, packetizing it down to a small package, and then running it on the edge on our devices because we had the software framework for them to actually do that and test it. So with that, we learned a lot of different feedbacks from our customers and our partners. And then a couple of months ago, when we announced our ARPEX 8 chipset, and that particular SoC now has a embedded deep learning processing unit. And because of that, we're trying to make it simple. We're trying to simplify that for our customers, because when we released the ARPEX 7 with that particular coprocessor that handles the deep learning, it was only on a handful of products, and then our customers had to figure out which products had that particular chipsets. Well, now moving forward, anything with an ARPEX 8 chipset is going to be able to handle deep learning processing, because that particular processor architecture that we've learned from is now embedded into our SoC design. And moving forward, that's going to be part of our DNA. So we want to make sure that in order to accelerate AI, we want to make it as easy for customers to adopt it. So whether they want to take advantage of it or not, having a hardware platform that already has it ready to go out of the box is going to be very beneficial. It's all about adoption. The more adoption we get with customers out there that want to look at different ways of utilizing AI, machine learning, deep learning as part of their overall solution is going to be very key for us. And that's what is going to differentiate us between a lot of other companies. The other thing that's differentiating us between a lot of other companies is our partnership. As you know, we work with not only Chooch, but we also work with a lot of companies across the stack. Not only from companies that work with us on the edge, but also companies on-prem and on the cloud. What we feel is that we feel that a lot of different companies in the AI industry, they have a very common strategy, is because if you think about other industries, you have companies that will try to sell you proprietary technology, and that's really not what we're here to do. We understand that AI is going to be a very complex topic and technology, and it's going to require collaboration. And that type of strategy is what we call horizontal. And what we mean by horizontal is we don't look at differentiating companies out there as competitors. They're more as partnerships. So we will work with anybody that wants to work with us. And by doing that, we will be able to cultivate a solution for the customer, because we know that it's not going to be just one customer that's going to solve one partner or one company that's going to solve a customer's problem. It's going to take several companies coming together to actually, collaborate and actually come to a conclusion or a solution that's going to benefit the customer's use case. And from that standpoint, we feel that partnership is going to be very key. And in order to facilitate that partnership, what we've done is we've opened up our ACAP platform to open source. And what we mean by open source is now it's available for anyone, people inside the security industry, people outside other industries, to take a look at our platform and look at what they can do with AI, with not only cloud, on-prem, and edge, but, play around with the whole ecosystem, and that we believe is going to drive innovation. So with that open platform, that open nature of our development framework, we hope to have, smooth integrations into a lot of solutions out there that are on-prem, that are also cloud-based. And we know that over the next couple of years, the processing that we're going to be able to produce on the edge is going to accelerate, and that's going to be very exciting. So there's going to be a lot of things where, the solution might be edge and on-prem, or edge and cloud, or a combination of all three. So really, for us, it's all about that horizontal strategy and collaboration and open source nature. That's really what's going to drive the AI, technology into our industry and beyond to other industries as well, too. And from that, a lot of things that has been happening is a lot of our customers now are coming to us with some very unique use cases on a lot of different things that we're working on with them on to try to solve. And some of these use cases are really driven by the end customer, and they're not even public safety related. They're related to a lot of other different problems that they're facing that are non-public safety or security related. They're operational. There's a lot of different things that they're doing from a marketing standpoint. So one use case that I can talk about was very interesting is that, we use a particular a customer had some problems with monitoring emergency exits, and they wanted to see when an emergency exit was blocked, because they were getting fined by OSHA in terms of, if you block an emergency exit, you're gonna have issues with not only government fines, but then you might have issues with liability, because a lot of things can happen during an emergency, and if you're blocking an emergency exit, there can be some liabilities and some monetary compensation that's a risk for a particular company. So what we did was we actually investigated that particular solution. When we looked at it, we're like, okay, so we have, we can build a model, and we can looking at AI and machine learning and deep learning and building a model to try to solve the problem, or we can look at other possible solutions. So the other solution we looked at was computer vision. So the one thing about computer vision and machine learning that a lot of people don't understand is that with computer vision, there's a lot of data that the sensor itself already sees on the edge before it gets into a machine learning model where it's going to learn what it's seeing, right? So from a computer vision standpoint, there's a lot of things that you can get from the image sensor, because the image sensor, before it looks at the data and puts it into a pretty picture that everybody here can see and relate to, there's a lot of data sets that are there. So if a lot of people out there that are familiar with photo editing, the RGB spectrum with red, green, and blue, these are different things that the computer vision can actually identify ahead of time. They can look at all the pixels on the sensor and figure out different hues, different tones, and things like that, and they can actually segment foreground, background, and things like that, but not go into the more deeper things, because in order for them to classify the more deeper things, you gotta take all that computer vision data and send it to a machine learning model or a deep learning model for them to understand what it is that they're looking at, right? So if I'm just looking for a particular object that's a red color, then I can use some computer vision data to kind of look at, okay, what are the reds in the scene, and then from there extrapolate the pixels from that red, and then maybe encode that into an image, and then send it over to like a machine learning model so that it can start to classify that particular object that's red, right? So there's a lot of different use cases, and the thing about computer vision is that computer vision is also very subjective, and it really depends on the sensor type and also the processor that's handling the computer vision data. So not every camera out there is going to have the same computer vision data. So it comes down to the sensor sensitivity, the processing of that particular data before it becomes an actual image. So from there, you want to have a good product or a good sensor that's going to give you quality information. And from there, then you'll be able to extrapolate the information that you need. So in this particular use case, in terms of blocking an exit, we felt that, okay, it might take a while for us to train a particular model to basically classify several different variety of objects, because we just don't know. The customer doesn't know what kind of objects that are going to be blocking that exit. So from that standpoint, instead of going towards the AI machine learning route, we actually went towards the computer vision route. And what we did was we used an OpenCV That's an open source computer vision, framework that's available out there. And we looked at a technology called entropy. So with entropy, it's kind of like a histogram of a particular image. It gives you all the different, a mathematical value of the image. And what that allows us to do is a lot of these emergency exits are very sterile, very static. The cameras were positioned over the doors in a way where nothing shouldn't be there. It had, consistent lighting throughout the day. And what we did was by using OpenCV and entropy, we were able to capture an entropy value of that particular scene, as a baseline. And then now, anytime an object gets into the scene, that entropy value is going to change. The histogram of that image is going to change. And because of that, we were able to set thresholds and sensitivities and alert on that because we don't know what object's going to be there, what size of the object. So based off of using this particular OpenCV computer vision technology on the edge, we were able to, create a application that runs on the edge that's able to at least identify. And then from there, it sends a snapshot and alert to a particular VMS or video management system, so somebody can visually verify if the emergency exit is blocked. But at the same time, we also tied that to an audio IP device where it created a automated message so that if somebody was putting something there to block the exit, it would alert them to please remove that object. So it was a very unique use case that involved a little bit, it started with conversations around AI, and then we ended up using some computer vision, technologies to actually solve the problem. Now, the one thing about computer vision and machine learning and AI and deep learning is that when you combine the two, it can be very powerful. And that's where the second use case that I have to talk about briefly is a very unique use case because we've always been asked, for the last couple of years, can we identify certain animals, certain objects? And, with machine learning and deep learning, we're starting to get to the point where we're able to classify people and vehicles. But with animals, there's so many different animals to choose from. So in this case, we actually worked on a project in terms of, utilizing both edge, on-prem, and cloud. So this is an example of using the full stack to solve this particular problem. So this particular analytic is to detect dogs in a particular training facility. So what we did was we actually wrote a particular code, running it on a Jetson Nano board that's an on-prem device, connected to an Axis camera. It's a pan-tilt zoom camera, PTZ, that can actually move, zoom in. And we were trying to create an auto-tracking solution where once it detected a dog, it would track that dog throughout the whole training facility so that it would always be in the field of view. So with that, this particular Axis camera did not have the processing power to run analytics or AI or machine learning at the edge. So we used a Jetson Nano board that can run a very, simplified model for image classification. But at the same time, it wasn't powerful enough to do the image classification that we needed. So we tied that to a cloud platform with YOLO V5 and a neural network that's out there that already has a huge library of existing, models for detecting dogs. So with that, we connected the dots, right? We connected this particular neural network that already has the models and the image and the data on identifying dogs. The Jetson Nano was the intermediate on-prem device that's going to be able to process the data between the edge devices to the cloud and back and forth. And then the other thing is that, once we got the information from the camera sent up to the neural network and it's identified that this is a dog, that information needs to be sent back. And then from there, we need to be able to code the PTZ to follow and track the coordinates of where that image was identified. So this particular solution is very unique. If you guys follow me on LinkedIn, I actually posted a video of the solution on my LinkedIn that you can take a look at. But those are hopefully two examples of some use cases that talks a little bit about computer vision, that also talks about a little bit about AI, machine learning, and deep learning, and how that all ties in within the whole stack. It's a very technical topic, and I can speak for hours on it, but I want to make sure that you guys are able to kind of get a high level overview of some of the unique things that can be done with AI, machine learning, and deep learning and edge devices. And that's where we work with Chooch a lot. Chooch is a great company when it comes to accelerating and building out models, and they give us great feedback on the type of images that they would want to capture from, there's a lot of things around that's accelerating the training around building models, and Chooch has a really good solution on accelerating the training of image classifications. And the thing that we try to advocate is, a lot of people know that with machine learning, deep learning, it's all about data, right? And they want as much data as possible. But you know what? It is, but then it's also not, because it's also about the quality of the data. So in the, in the technical world, when it comes to programming, we have this thing where we call garbage in, garbage out. So if you send it a lot of bad data, you're going to get a lot of bad data on the output, right? So really, when it comes to the unstructured data that machine learning and deep learning loves to be able to learn from images and video, it's about the quality of the data. So if we can give it good quality video and images, you're going to get very good quality output. So that's a very important to understand, is that, not everything is apples to apples. And going back to that computer vision aspect of how the computer vision side of the sensor, it understands the intensity of color, right? Because, of computers, they don't know what red, blue, or what white is, right? They know it through values in terms of the RGB spectrum and the numbers we put into those particular intensity pixels, right? So with that, you have to worry that, certain sensors, they might not detect red as red. It might be a little bit off hue or off intensity. So this is very important for the machine learning world and the deep learning world, is that getting good quality data probably trumps the quantity of the data. Yeah, everybody wants more data to build better models, but you can still do really good outcomes with good quality data and small sets as well too, but it's all in the process and how you do that. And I know Chooch has been very good with the way they implement and build models, and this is why we like working with them. And we're always open to feedback on what can be done on the edge. We know we're not the end goal here. There's a lot of things that can be done in collaboration, and that's why that horizontal strategy is so key to us. But we also know that our edge devices are becoming more and more powerful. It's going to offer more information and more data for customers like Chooch and for our end customers. So we want to know what kind of information they want to get access to, and to help accelerate the AI technology as a whole. So with that, for us, our approach is always this ecosystem solutions approach. We're going to need partnerships out there to help a lot of our customers' problem, and they have a lot of unique problems. And that's the thing that we thrive on. We love the challenge. We love to be challenged because we feel that we can actually solve a lot of these problems with technology. So with that, I'd like to close my end of this segment to basically state that, at Access here, we have a model of innovating for a smarter and safer world. And we've, for the last couple of decades, we've been working, on the safer side really well with getting everything on the network and really applying that to a lot of our diversified portfolio. And the smarter side, we've been doing that also in the last couple of decades with a lot of different solutions that are being run on the edge. But this AI technology, this paradigm is going to be very, very impactful, not only in our industry, but in other industries. So we know that it's going to be beyond just public safety and security. It's going to go into operational efficiencies. It's going to go into marketing. It's going to go into other different realms where video is going to be very valuable, and these images are going to be very valuable. And from that standpoint, we see very positive outlooks on how AI is going to impact our industry, how it's going to impact us as a company. And with that, I'd like to thank you for your time, and really thank you to Chooch and the rest of the people here that invited me to come here and speak on Access behalf. So have a great day, guys. Take care.